Okay, Year 12, this one is for 23D.1, which is part of the beginning of the binomial distribution section. And so we're going to use our knowledge and understanding of binomial theorem and Pascal's triangle to help us work out the probability in certain experiments. The only difference is this will work only with sampling with replacement. So that means, let's say you pull a marble out of a bag or a number out of a hat or something, it gets placed back inside. So the probability actually doesn't change. It goes back to what it was originally. So binomial probability here, binomial distribution only works for sampling with replacement, okay? When it is without replacement, it's something called hypergeometric probability distribution, this model, but it's not part of our course, so don't worry about it. We're just going to do sampling with replacement, and this is related to also binomial probability distribution, so it's helpful for when we want to look at that distribution as well. So normally we're looking at basically just an event and like the non-event or the complement, or what we typically say is like success and fail, okay, whether it happens or doesn't happen. And we repeat it a number of times. We call the trials independent trials because you put the number or the marble or the ball or whatever it is back in, so it starts from scratch again. So the second and third, etc. trial does not depend on what happened last time, because you just like start from the beginning again basically. So this is called a binomial experiment, okay? Normally we denote a success with little p, and it's got to be constant, as we said, for all trials. So let's say probability of getting say a 6 when rolling a die, 1 out of 6, but it still continues to be 1 out of 6 each time. That's probably not the best example because you're not putting something back in, but let's say you've got numbers 1 to 6 on little cards in a bag, and you're pulling a card out, and then after you read out the number you put it back in, so the probability of you getting the same event that you were looking for is the same, okay, over and over again. So they're complementary events, okay, right? Okay, success and failure, complementary events. So probability of a failure is going to be 1 minus the probability of the success. Makes sense, yeah? So your random variable x, okay, it's the total number of successes that you get in the n amount of trials that you do. Now, it's easiest to see binomial probability distribution through an actual example. So let's do this example here. Let's say you've got a spinner like this. It's got 3 sides of blue, 1 side is white. So probability of getting blue is 3/4, 3 out of 4, and white is 1/4, 1 out of 4. Now, let's say getting blue, we're going to denote getting blue as successful and getting like white is the failure, okay? So we're going to let P be the probability of getting blue, so little p equals 3/4. So that means the probability of getting white is 1 minus p, which is 1/4. Easy. Let's say we're going to do the spinner, or like spin the spinner 3 times, okay? We're going to do 3 trials. So here's our tree diagram. Let's look at the tree diagram first before we actually look at the calculations. So you can see over here, here's our tree diagram, and the first event is your first spin, and then second event is your second spin, and your third event is your third spin. And you can see each time, obviously, when we spin it, you can get blue or white, or blue or white, or blue or white. And you can see, can you actually see here, the numbers, the probabilities have not changed, right? Because it just, starts from scratch again. And for the white, it's 1/4. Okay, so I'll just rub that out. Now, if you have a look, if we write these out, we could write them out as on the end, the different, like the sample space you could get, blue, 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 white. Yeah, blue, white, blue, blue, white, 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 blue, blue, white, blue, white, 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 blue, white, white, white. Okay. And we understand that if we want to find the probability of, say, getting blue, 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 you go along the branch, right? Blue, 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 and we times it, right? We go 3/4 times 3/4 times 3/4. That'll give you the probability of getting triple blue, okay? So your random variable x, okay, let's say let it be the number of successes or the number of blue. So you could get, so what are the possibilities? X could be 0, 1, 2, or 3 blue, right? You could get 1 blue, 2, 1, 2, 0, 1, 2, or 3, okay? So we've got to go through each case. So let's start with P, probability of x equals 0. So the probability of getting 0 blue, okay, is going to be, if you get 0 blue, that means that's white, 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 right? So that's 1/4 times 1/4 times 1/4. Makes sense. So we get 1/4 to the power of 3 if we want to write it with in index form. Let's do probability of x equals 1, okay, or getting 1 blue. So, but that means you have to have 2 white. It doesn't mean just 1 blue on its own. You're spinning it 3 times, so you have to include 2 whites. But there are 3 different ways you can do that. You could get, let me highlight in green for you. You could get, yeah, blue, white, white. Where is it? Over here. Blue, white, white. You get white, blue, white, or you can get white, white, blue, right? Those 3 in green that I've highlighted in green give you 1 blue. And what we would normally do back in like year 10 probability is we would just multiply along this branch, right? And get an answer. And then you'd multiply along this branch, those probabilities multiply together. And then you do this branch. And then you would add all 3 together after you've done those calculations. Okay, but the thing is, they're actually all the same number because they're all like 2 whites and a blue. So that means you're doing 1/4 times 1/4 times 3/4, but just in a different order, right? So that's why here, what they did was the shortcut is just go, well, you've got 1/4 times 1/4 or 1/4 squared times 3/4, but then times 3 because of the 3 different ways of getting it, the 3 branches. And then here you've got probability of x equals 2 or getting 2 blues and a white. Now let's see how many ways are there of doing that. Let me just rub out this pink bit, otherwise you get confused. Okay, so now we're going to go for 2 blues. Where's 2 blues? So there, 2 blues and a white. There and here. Okay. Again, same idea, but because you got 2 blues, it's going to be 3/4 times 3/4 somewhere along that line times 1/4 for the white. But there's 3 different ways of getting it, so that's why you've got times 3. And then the probability of your random variable being 3. Oops, hang on, change the highlighter. Yep. Is 3 blues. So that's easy. 3/4 times 3/4 times 3/4. Makes sense. And there's only one way of getting that. Excuse me. So the thing is though, there's a really cool trend here with the numbers in front though. Excuse me. I'm going to show you down here. Excuse me, year 12. So if you go down here, they've just rewritten out, more nicely what we had on that page previously. But instead of writing the times 3 on the end, we've got it at the front. But if you notice, technically there's an invisible 1 here in front of this one, and there's an invisible 1 here. And so when you can hang on, 1, 3, 3, 1, what does that remind you of? Okay, have a think. It is Pascal's triangle, right? When you have like 1, 2, 1, and 1, 1, and 1, right? So we add it, and then you get 2, 1 plus 2 is 3, 2, 1, 3. So those numbers in front, that represent how many ways you can get to that combination is actually formed by using, you can use that combination or the choose function. See, this is what they've got written here. Yeah, the 3 choose 1. Okay, but it's just the numbers in your Pascal's triangle, which is very, very cool. So here you've got 3 choose 0, right? Which represents getting 0, yeah? Okay, getting 0 blue, right? Is that blue? Yeah, 0 blue. And then on the next one, 3 choose 1, that's getting 1 blue. 3 choose 2, getting 2 blues out of the 3 trials. You're doing an experiment, and then getting 3 blue. Okay, and obviously the first and last one gives you 1, and then the 2 in the middle give you 3. So you just got to use the calculator. And then you can see here, then you just put in the calculator, you get these 4 values here, sorry, of the probabilities. And hopefully they should add up to 1. Okay. Here's a spike graph for 0, 1, 2, and 3. You can just see on the right, it's just got that numbers going all the way up to 0.219. And if we want to write it in general form, here it is here. Capital P, or probability of your random variable x is equal to some number x is equal to 3 choose x times 3/4 to the power of x times 1/4 to the power of 3 minus x. In our case, we've done, I think 3, in our case, little x is 0, 1, 2, or 3. So we could have gotten 0, 1, 2, or 3 blues. Okay. All good. So what they do here is just to prove, it's just the working out, to show that it adds up to 1. So you've got px 0 blues, probability of getting 1, getting 2, and getting 3. And we're adding up these numbers from before, okay, from your binomial expansion, okay, and you will see that it actually gives you 1. And it actually kind of makes sense, because if you write it down together as like your A and your B, like if that's A and that's B, remember when we learned A plus B to the end, for example, when we read out the expansion, but A and B here happen to be 1/4 and 3/4. So 1/4 plus 3/4 is 1, so 1 to the power of 3 is 1 anyway. So that's what's always going to happen when you've got binomial. Or would it be helpful if I left that in there for you? I'll left that in there for you. But it's that's what happens when we do binomial probability probability distribution for experiments without replacement. Okay, sorry, with replacement. I'm saying the wrong thing. With replacement. Okay, let's do an example together, and then you can just practice. So here we've got, it says expand 9/10 plus 1/10 to the power of 5. Okay, straightforward. Let's do this first, just a bit of revision from binomial theorem. So if I've got 9/10 plus 1/10 to the power of 5, technically we've got like 5 choose 0 to begin with, but we know that just gives me 1, but I'll write it out fully for you. Then you've got the first one, 9/10 to the power of 5, technically times 1/10 to the power of 0, but that just gives you 1, plus, then the next one we're going to have 5 choose 1 times what, 9/10 to the power of 4, remember the power goes down, and the other one the power goes up to the power of 1, plus 5 choose 2, and then we've got 9/10 to the power of 3, 1/10 to the power of 2, plus 5 choose 3, maybe we need to neaten that up a little bit, 5 choose 3 of 9/10 to the power of 2 times 1/10 to to the power of 3 plus 5 choose 4. Sorry, I have to zoom out. 5 choose 4. 9/10 to the power of 1. And then 1/10 to the power of 4. Plus, and then last, 5 choose 5. Then you've technically got 9/10 to the power of 0. You can leave that out if you want to because it equals 1. And then you've got 1/10 to the power of 5. Now, if we put these numbers in the calculator, I'll do Pascal's triangle. I'm not going to do the whole thing, but I'm just going to simplify the choose bit. So this first one will be 9/10 to the power of 5, right? Because this is 1 and that's 1. And then the next one, 5 choose 1, is actually 5. So you get 5, 9/10 to the 4 times 1/10 plus, and then this is 10 in front. Then you've got another 10. Oops. 1/10. Oops, hang on, I wrote the wrong thing. Power of 9/10 to the power of 2. 1/10 to the power of 3. And then 5 choose 4 is 5. And then you've got 9/10 times 1 on 10 to the power of 4 plus, and then lucky last, 1 on 10 to the power of 5. Okay, because that's 1 and that's 1, right? Okay, all good. So there's our expansion. Now question B says an archer has a 90% chance of hitting a target with each arrow. If 5 arrows are fired, determine the chance of hitting the target. So the probability here of like a success, okay, is going to be 9 out of 10 or 90%. Okay, so that's the success, i.e. hitting a target. Okay, so if we're looking at part 1, which asks if we hit the target only twice, so that means we need 9/10 to the power of 2. So that is, where is that in our sequence? It's this one, right? 9/10 is to the power of 2 there, because that's where that one there is when you have P of X equaling 2, okay, which means the probability of hits target twice. Okay, so I'm going to improve that arrow. And so we just need to put in the calculator. 10 times 9/10 squared times 1/10 to the power of 3. And just going to put that in the calculator, and we should get 0.0081. Very small probability of hitting it twice only. Now part 2 says, this is where the language is tricky. It says at most 3 times. So that actually means we want it hitting like 0 times or 1 or 2 or 3, but not 4 or 5, right? It says at most 3. So the probability means we want X, the random variable to be X, to be less than or equal to 3. Does that make sense? So it's going to be P of X equals 0 plus X equals 1 plus P of X equals 2 plus P of X equals 3. Okay, so we've got 1/10 to the power of 5, right? That's the last one. Oh, sorry. Yeah, the last one. Because that's when you have 0 hitting the target, right? Then P X equals 1, so hitting the target once is going to be 5 bracket, what's that, 9/10 to the power of 1, and then 1 on 10 to the power of 4. Does that make sense? Plus, and then where's px equals 2? Where is it where you hit the target twice? That'll be 10 9/10 to the power of 2, 1/10 to the power of 3, plus, and then hitting the target 3 times is going to be 10 times 9/10 3 to the power of 3 times 1 on 10 squared. Alrighty, all good. And then you just go do it in the calculator, and I think we should get approximately 0.0815. Don't forget 3 significant figures where relevant. Okay, so that's the chance of you hitting the target at most 3 times when you fire 5 arrows. Okay, so that's it for 23D.1. There's a couple of questions for you to try, so please practice and make sure you wrap your head around it. And if you want more practice, then get the questions out of the Oxford Insight book, 23D.1, and it is on page 621 in your textbook. Please have a go at the questions, and then we'll get on to the next one.